Okay, this is lesson 39. Lesson 39. We are starting with the second half of 39, and this is the latitude on Earth problems. And so, what we're going to do is we're going to figure out, guys, that if I took Earth, and I cut it straight through like the poles in the center, right? And you looked at it from a side section, you would see a circle. I think everybody should agree with this. And what we're going to do is we're going to think of the Earth as a circle so that I can find distances between cities or between the equator. The equator is halfway through, right? Around the middle of the Earth, to how high or the height of a city in latitudes. Do you guys remember? Do you guys even know what latitudes and longitudes are? Yep. Latitudes are your horizontals. Longitudes are your vertical lines that are wrapping around the Earth. And each of those represents a certain degree. So when we talk about latitudes, if it's 5-degree latitude, that means you're 5 degrees from the center to the equator and up. So on the Earth, so our equator would be something like this if we're actually talking about the Earth itself. The center, and then, well, that's a radius. Each one of these lines would represent a new latitude, right? And each one of those has a degree based on how far away from the equator it is. So there's 1 degree, 2 degree, 3 degree, 4 degree, so on. And so what we're going to do is we're going to find out that what is the arc length of any particular city is away from the equator, or we can figure out how far 2 cities are apart. I think we have done this before. I want to say we have. But today, since we learned what radians are, and we start to realize that the world around us revolves around radians. Because pi is a naturally occurring number. And pi is radians. And so, what we're going to do then is we are going to say, hey, I can find the arc length. Now remember, arc length, guys, is if I took and said, hey, I am 50 degrees latitude, that'd be 50% or 50 degrees up from, not 50%, but 50 degrees up from the equator. What's the arc length to the equator? What is that length right there? So again, we go back to that cross section and say, hey, thinking of a circle, we're thinking about arc length. How much of the circumference am I using? When we had degrees, guys, we used this bottom equation. But take a look at this bottom equation. What we did was, hey, we took 50 degrees, and we divided that by 360 to figure out the percentage of the circle I was using, right? We did the same thing for area of a sector. How much of the circle am I using? And then you multiplied it to the arc length, or circumference, sorry. Circumference is 2 pi r. If I wanted to know the area of the sector, I'd multiply it to the area of the whole circle. So that's what we did. But wait a minute. Wait. Look at this thing right here. You've seen that before. 2 pi over 360. Wait a minute. You didn't see it that way. But what if I reduce that? What does that become? Pi over 180. Since when did you ever take an angle and multiply it by pi over 180? You just did it yesterday. When you were converting from degrees to radians. So your first step, technically, when we were doing it the old-fashioned way, without telling you, we converted it to radians. So now here's the cool thing, is that today, or our problems from here on out, they're going to either give you degrees, or they're going to give you radians. And if they give you radians, you're thinking, oh, this is so much easier. Because why? Because above says that the arc length is equal to theta in radians times the radius. So if we said we were pi over 3 radians, then you just have to multiply by whatever the radius is. And if the radius was 3, then the arc length would be pi, or 3.14. So it can make it a lot easier. So there's a couple different ways. If you're given degrees, you convert it to radians and multiply it by the radius, or you plug it in that equation in the bottom, or if it's in radians, just multiply by the radius. Okay? Here we go. This one kind of talks again what's a latitude and longitude, actually latitude only. Longitude is different, and I do believe about half an hour north of us is the 45th prime meridian. I think it's longitude, it's latitude, I think. I'm not sure. Yes, we're almost halfway between the North Pole and the equator. It's about a half an hour or so north of here, on 41 or something like that. They have a marker on the side of the highway. Okay, so the shortest arc from the point to the equator is a latitude, okay? So, I know I spelled it wrong, so it's Los Angeles, or Los Angeles. It is 34.5 degrees north of the equator. How far is LA to the equator if a diameter of Earth is 7,920 miles? So how far in miles, if I drew a circle, there's the equator, there's Los Angeles, or Angeles. This right here, guys,
That's how you spell it?
34.05. That's how I spelt it. That's the way I'm going to say it. Okay? How far,
Angeles.
guys? What's this distance? What's that blue distance? So, if we're in degrees right now, if I want to use the fact that I want to multiply it to the radius, I need to convert 34.05 to radians. Is this going to be a nice number in radians? It won't even come out to a nice fraction necessarily, right? We'd have to manipulate it more to make it a nice fraction. But, how do I change it again?
Divided by pi over 180.
Other way around. So 34.05 times pi over 180. And if you do that, you now converted this into radians. I think all of us would agree that this is not a nice number. But if I put it in my calculator will give me a number. Right? Make sure you use the pi button and not 3.14. Hey guys, could I make my life a little bit easier and leave that on my calculator? And then just multiply by the... Not reciprocal. What's the other half of the formula? R. Radius. I want to do theta times R. So what is R? What is the radius? It's 7,920 divided by 2. Which is?
Mike, can you make your age, please?
So, 3,960. Am I correct? I'm not sure. I'm just trying to think of what we did last hour. I mean, you guys have calculators. Might be helpful. Okay, so I just take that number that's not so nice and multiply it by 3,960, and you end up finding that the distance between the equator and Los Angeles, it's the way I spelt it, it's the way I'm saying it, guys, is how far? Okay, guys, you guys should all be taking your calculators out and working this out. Here's a cool thing, guys. It could be, instead of just the equator to this town, it could say that the distance in degrees, that angle between towns, say Green Bay to Los Angeles, is 70 degrees. You can find the distance between two towns on the earth, okay? That's one way to do it as well. So how far are we, or is Los Angeles from the equator? Cammy.
Oh, you're looking at me.
Yeah, I thought you had it waiting there on your calculator.
0.59.
0.59? No.
Oh, I have a decimal. Wait, no.
You gotta multiply it.
Multiply it. There we go.
Somebody, come on. 2,800? 300? 23053 37. Guys, the distance from the equator to the town was 2,353.37 miles. Okay? Guys, now the last part we have to do is talk about the 5 different ways that we could write a line equation. You guys know 3 of these. You guys know point slope, y equals mx plus b. You know point slope. Point slope is y minus y1 times m, or equals m times x minus x1. You've used that. And we've also seen general form before. ax plus by equals c. Those are all things that we've seen and actually used. If it was in general form, we use cover up to graph it to find our x and y intercepts. If it was in slope intercept form, it gives us a slope and an intercept. And point slope we generally use to get to slope intercept form. The other 2 that we have up here is 2-point form and double intercept form. Well, 2-point form, wait a minute. Doesn't that look really close to point slope? What's the only difference? And when I'm asked to do, or it says write it in point slope, I will leave it as y minus 2 equals 3 times x minus 5. I am not going to actually do the distributing and gathering it up. You leave it exactly like that. So I do the same thing for 2-point. 2-point, guys, takes out the m and actually puts in its place what? Is that the point, the slope formula, right? y2 minus y1 over x2 minus x1. So it takes out the slope and actually uses the formula in its place. The exact same thing. Not that big of a deal. Double intercept form, though, guys, gives us double, or 2 intercepts. Well, when you have a line, there's only 2 intercepts. There's an x-intercept and a y-intercept. Here's the cool thing. A is your x-intercept, B is your y-intercept. And the whole idea is to have the number that the intercept is on the bottom. Wait a minute. Double intercept and general form look really close to each other. They're almost the exact same thing. But on general form, it equals C. On double intercept, it equals 1. So to get to double intercept form, I will put it into standard form and then divide everything by C. The only thing about double intercept form is that x and y on top have to be by themselves. That means anything that's next to x and y has to drop to the bottom of the fraction. So that allows me to say, hey, that is right there is my x value and my y value of my intercepts. All you have to do now, guys, is convert these to the ones it wants us to. The first one, it gives us slope-intercept form. I want general form. And when we use general form, we don't have fractions anymore. I want integers as my constants. So 2's and 3's and 4's and negative 3's and negative 5's. But no halves, no fourths, no 3/4, stuff like that. So I got an equation. It's got an equal sign, but it also has fractions. What you do to one side, you do to the other. But what can I do to get rid of my fractions? I can multiply both sides by the LCD. Multiply both sides by the LCD, it gets rid of all of our denominators. You guys have done that before. What is the denominator here? Or the LCD? 15. 15 and 15 if I distribute that 15 through, right? What's y times 15? 15y. What's 15 times a negative 7/3? Reduce it. What's 15 divided by 3? It's 5. What's 5 times negative 7? Negative 35x. 15 15 divided by 5 is 3. Standard form, guys, has x's and y's on the same side, so what do? I'm going to just add 35x to both sides, and I'm done. Now, in standard form, or general form, sorry, x's went first, so it'll be 35x plus 15y is equal to 3. Done. Any questions? That's how easy they can be. Now, I would say, though, that they're also going to not only put x first, but they generally make it so the x is positive. So that means multiplying or dividing everything by -1 to make that leading term positive, please do so. Because if you check your answer in the back of the book, they may have it always be a positive x. And then everything else can be positive or negative, it doesn't matter. Now, the next one says write it in double intercept form. That is considered kind of in general form. But remember we talked about that the general form and double intercept form looked really close to each other. They were really close to being the same. And so what I want to do then is put it into general form. And once I get it in general form, I'm going to take care of that c value. So how do I get this in general form? How about subtract 4? Now, it's in general form. Yay, but that's not what I want. I want double intercept. Double intercept has 1 where that -4 is. So what do? How do I get rid of a -4 and make it a 1? Divide by -4. And so, if I divide this by -4, I have to divide that whole entire side over there by 4, right? So M1 is equal to, but if you think about it, that means they have a common denominator. I can split them apart. So I should have something like 2x over -4, and I have to subtract 3y, but I'm dividing that by a -4. So then what? So it should be a positive. So it should be a positive 3y over 4. That's a y. Fix that. Is everybody with me so far?
Yes.
It's a -3, but we're also divided by a -4.
No.
Oh, sorry, yes, -2x. You are correct. I have a -4 on there. This screen is not letting me show that. It's a 4. Now, at this point, can I simplify the 2 over -4? So shouldn't that be x over -2? Right? Plus 3y over 4 equals 1. Hey, from this, I can actually tell you that the x-intercept is going to be at -2. But the y-intercept, is that at 4? Or is that 3? What is it? I don't like it because I can't have the 3 with that y. So I need to get rid of it. And how do we do that, guys? We do that by dividing by that fraction. Dividing not by just that fraction, you divide by the reciprocal. Because if you divide by a fraction, what do? You flip and multiply. So that really means this is x over -2 plus y over, what would the fraction have to be, so that when I flip it, it becomes 3 over 4. 4 over 3 equals 1. As 3. It's a negative 2. So my x-intercept's negative 2. My y-intercept is 4/3. Why is this so powerful? Guys, go to graph it. 1, 2. There it is. 1, 2. 4/3 is just over a third of the way there, right? There it is. I just integrated the line equation. It's easier to identify your x and y intercepts in double intercept form than even using general form, or standard form as we generally called it, by using cover-up. You get the same idea. If I plug a 0 in for y and solve for x, I will get negative 2. You solve for y by plugging a 0 in for x, you'll get 4/3. So it's all about taking those 5 different forms and switching them appropriately. Your homework is day 3, page 283, 1 through 3, 5, 8, and 9. And 5 better look really familiar to you guys. Have a great day.